Hi, this is Brad Seacott with Terracom. In this short video, I'm going to quickly go over the difference between the Yokogawa AQ6380 and the AQ6370D. Now, there is a new version of the 6370 that's just coming out. That's the 6370E, and I'm going to address that in another video. But for the intentions of this video, and particularly the optical performance, they're going to be the same. The D and the E are the same. The E is going to have more of the form factor and the updated electronics that the 6380 has. Okay, so let's go ahead and get into this. The best way to do it, well, of course, you go to the Terracom website. If you want to contact any of us, just go to regional line cards, select your region, and the contact for your sales engineer locally is there. So let's go to About and Partners, and I'll explain in a second why I do it this way and don't go directly to Yokogawa. Here are the partners that we represent. Let's click on Yokogawa. Okay. The nice thing is it sends us right to the optical landing page for Yokogawa. Okay, and as you can see, I'm just going to zoom out a little bit here. As you can see, Yokogawa sells a lot of different equipment, and it can be a little difficult to get to where we want to go. So we'll just go right to the optical. This is something interesting. This is a 6380 OSA live stream that one of the application engineers is going to answer some questions about. And so there's all kinds of things here. There's resources and documents and downloads and so on. Okay. What we're really interested in is products. All right. And so I'm going to go ahead and go to the spectrum analyzer page. Okay. And then here are our spectrum analyzer choices. And I've already opened up tabs for the 6380 and the 6370. Let's go to the 6380 because there's some comparison on that tab that is going to be important. Okay. So there's a video there that Yokogawa produced. I highly recommend watching that. Some front panel and rear panel shots, but where it's really won and lost with the 6380 versus the 6370 is the 6380 has a 5 picometer resolution, okay, whereas the AQ6370 is a 20 picometer resolution. So already that's a huge difference, and that's probably the number one difference between the two. All right, and you can see that reflected in this picture here. Okay, so here's a picture of a DFB. Purple is the 6370D-22. Okay, and the -22 has a little bit better close-in dynamic range. So you'll see with a -12, it'll kind of come out a little bit like this. Okay, not that much different, but different. All right. The 6380 is significantly finer. So if you need high resolution to pick out features in your laser or other optical features, the 6380 for a monochromator-based OSA is the highest resolution that I know of on the market. Okay, but what comes along for the ride with the resolution is also the close-in dynamic range, and you can see that in the picture here. The dynamic range is defined as the point here down to the point at the wavelength that you're looking for. So 10 meters off, 10 nanometers off, 5 nanometers in, so on and so forth. So the close-in dynamic range for the 6380 is 65 dB close-in. Okay, so it's very high, and it's going to set the 6380 apart from not only other monochromator-based OSAs, but also other technologies like coherent technologies and Fabry-Perot or Michelson interferometer technologies. That's why you would need an AQ6380. If you need to see that type of dynamic range, that is the number one reason to choose a 6380. All right, there's a couple of other things. It has a high stray light suppression ratio. And that comes with I wouldn't call it a penalty, but a change in the design, okay? In all of the 6370 series, 6360s, all of the 637X series, there's been a free space input into the front of the OSA. And that's really good because you don't have to worry about, you can take APC, PC connectors, you can put in multi-mode connectors, so on and so forth. The 6380, to get that high stray light performance, they went to a single mode fiber at the input. And so that gives you really good performance, but you have to be aware of it, that there is a fiber on the input. Okay, so another difference is the wavelength range. The wavelength range on actually, you know what, the best way to do this, let's go ahead and just look at the data sheets. So what I have here is I have a 6380 data sheet on my left, and I have a 6370 data sheet on my right. Okay, and let's just zoom this in a little bit. All right, and so we can do a little bit of a comparison here. The first thing that we're going to, and certainly you can get both of these data sheets from the website, and I encourage you to do that. Eventually, I'm going to do a comparison spreadsheet, and when I have that, I'll be able to send that out. But I don't have one yet. Wavelength range, standard wavelength range on the 6380 is 1200 to 1650, whereas the 6370 is much broader, 600 to 1700. Okay, there is an option to lower this 1200 down. I have to look up and see what that option is. It is not listed in the online yet, but if you need to go below 1200, let me know and I'll let you know what that option is and what the cost is. There's a couple other things. Span is different. Here you can see the wavelength range, or this is wavelength accuracy. You can see wavelength accuracy is much better. Plus or minus 5 picometers versus plus or minus 20 picometers. The high performance is plus or minus 10 picometers. Okay, so that's starting to get close to a wavelength meter type of performance. Wavelength meters are going to run anywhere from 3 picometers, plus or minus 3 picometers, to plus or minus 0.3 picometers, depending on which model you purchase. Okay. Linearity is better. We can go down and through all these specs, but really, I think the thing that I want to point out is these, from an optical perspective, this picture describes the difference. And that's why the 6380 is more expensive. There's a couple of other things. The 6380 has a faster sweep speed than the 6370. It has a gas purge. So that you can, it has a gas purge in the back so that you can purge a neutral gas and take care of any water vapor absorption issues. The other thing that's interesting about the 6380 is it has automated wavelength calibration. All right, and what that means is that the wavelength calibration cell is built into the 6380 just like it is in the 6370, but instead of having a connector on the front, so let's go ahead and take a look, you'll notice that there's no connector for output for the wavelength calibration. The reason why is because there's an internal optical switch, and so when you push the button and do a wavelength calibration, it will automatically switch in the cell. There's no need to connect a cord. And you can set that up to calibrate automatically, or you can set it up to calibrate manually. So that's kind of a nice feature. By comparison, if you look at the 6370, which this is here, this is the calibration output, and the way that you calibrate it is you put a fiber jumper between the two. Okay, so that's kind of a quick update. I have more information if you'd like. I would encourage you to go and look at the 6380 and the 6370 data sheet. And if there's any questions, get in touch with us. Thank you.